Cool, thank you very much. So, I'm Ramey Myers, this is Hussein Nasser. We're really excited. This is the first year in production of the utility network. And at the end of the first year, we have over 60 utilities across the world that are looking at scope, considering migration strategies. And a few that are interesting to talk about is one, National Grid in New Jersey is the first utility to go live with the utility network, and they just went live in November. Guam Power Authority is expected to go live within the next couple of weeks. Duquesne Light should start going live in second quarter, and Mississippi Power Company is targeted in fourth quarter. And they're leading the spearhead for the entire Southern Company and Southern Company Gas. Really interesting, in Northern Europe, Ørsted, Lisa, Hefselen, and Ine have spent the last 2 years constructing a data model. Can you go back? Have spent the last 2 years constructing a data model to coordinate between Norway and Denmark. And as a result of their efforts, they've had 12 additional utilities across Europe start collaborating. And the vision is that there will eventually be a European-wide data model sitting on the utility network platform. Go ahead. So some of the drivers that are pushing utilities toward the utility network is safety. Safety's critical. It's by far, the most important aspect. So the ability to have high precision data with better accuracy and to leverage the Z values that you saw in Pro and be able to do things in Scene are going to enable utilities to do better clearances and have better analysis of their systems. The customer experience is equally important. The ability to be able to read data from meters and be able to predict load requirements, reduce outages, big deal. O&M, operation and maintenance budgets, have been hit drastically in the last 5 years. And it's anticipated that utilities will use utility network to sharpen their asset management focus, to be able to fine-tune where they need to do their scheduled maintenance and how they can reduce costs from it. And then grid modernization. Over the past 10 years, utilities have been upgrading and providing all these new remotely operated devices and meters and monitors, and they didn't have a platform to be able to see it all in action. And we anticipate the utility network will play a big part of that. And then finally, innovation. Innovation is critical because utilities are constantly moving forward in terms of technology. And the utility network will be able to provide a sandbox that they'll be able to test their technology on and do some predictive analytics and measurements of how to work. So let's see how these drivers work across the entire utility. So looking at blue, there's our core drivers right there. And we anticipate that we're going to be building out focused demonstrations of technology across these drivers to be able to envision and show utilities how they can get rapid return on investment. You don't have to wait until you have full implementation before you could start getting product out. So we think that's going to be a critical part of the messaging moving into 2019. Go ahead. So utilities are interesting. For years, they've had their entire workflow centered around maps, paper maps, GIS maps, schematics, things like that. But now the ability to take your utility network and be able to derive schematics from the network and have that second level of dimension, and then be able to explore features at scales, honestly, traditionally were not done in GIS. So with containment associations that Hussein will go over, you'll be able to go inside of features like substations or pump houses and see the intricate details. And then be able to do advanced analytics off of those intricate details. And not only just do analytics, but even examine those things over time. So be able to leverage the new branch versioning technology to be able to go back to a historical moment in time, or be able to leverage your system forward. And then finally, 3D. 3D is going to be a very big thing for utilities. The ability to be able to extrude up, to project up your features in the air or features underground are going to be critical. So how does it work? So first, let's start with the utility network domains. It's two domains. An operational domain, which is like a consumer product, like gas, electric, telecommunication. Interestingly enough, even rail. There's a rail provider in Europe that is currently doing some proof of concept on the utility network. So these commodities have the ability to break down into tiers. And a tier is basically the way the business operates. So as a transmission, does it provide regional support, or as a distribution, does it provide local support at the community level? And then having feature layers to represent those tiers. And those feature layers are honestly, they're just points, lines, and polygons. But for the operational layer, they represent things. So an operational device is a point that has operational characteristics. It can be open or closed. It has some sort of measurement, a load or flow, or it could be a controller that establishes the properties of the entire network. And then you got things like junctions that are connection points. They're still operational. They have connectivity, but they're not smart, if you will. They don't open or close. They don't send signal. You've got assemblies, which are a simple representation of maybe a number of devices. So for example, an assembly could be a switch group or a transformer bank that when you go into containment at that assembly, you see the individual transformers displayed out. And then finally, you've got lines. So lines are our connective features. They're our wires, our pipes, the things that transmit and send signal or transmit load. And not only do we have lines, but we have this new feature layer called a subnetwork. And a subnetwork is a general aggregation of that line. It gives you all the properties of the circuit or the feeder that line is supporting. And then obviously, you've got attributes that describe these. But traditionally, we've used subtypes to kind of break them down. And now we have these two new terms, asset groups and asset types. And asset groups are kind of a generalized term. So for an operational device, I might have a switch as an asset group. That's my generalized term. And then the specific definition underneath it could be a single-phase switch, or maybe a recloser switch. So having that functionality to be able to display the entire array of assets that have connectivity is going to be critical. And it's going to be critical to be able to display at all scales and at real utility level performance. So we also have structural domains as well. And these structural domains are a little bit more generic. If you think about our operational features as things that are connected, structural devices, structural points, lines, or polygons are supporting features. So for a wire in the air, that could be my pole that's holding the wire up in the air, or it could be some sort of platform that equipment is on. If it's a linear feature, it could be a trench or a duct. Or if it's an area, it could be a substation or maybe even a cabinet. So it's truly, these features are at all scales. That's okay. So now that we've got better data, we need better rules to be able to manage that data. We've got two types of rules. Our network rules establish connectivity. They establish, structural or containment associations. And they do that by point-to-point or line-to-point type relationships. And then we've got attribute rules. And these are the things that can calculate. They can propagate information based upon an event or a trigger or an edit. Or they constrain. They can prevent you from making bad data because of an edit or event that you did. Or they can validate. So this could be your actual rule weights until you rebuild the index. and then it'll come back and it'll throw you an error and says, hey, you didn't array your network correctly. Go ahead. So now we've got rules and we've got the data. Let's talk about the functionality. And the premier element of the utility network is the subnetwork. So this is the feeder, the operational system that's all integrated. So if one part of your feeder or circuit goes out, the whole thing goes out. So this is represented by subnetworks. And it's a collection not only of your lines, but even the operational devices, the points, and all the things that are within it. And you've got the ability to aggregate and calculate the characteristics of that circuit up. To provide information about the circuit properties, we have controllers. So controllers are your starting points. Or if you've got a gravity feed model, it could be your ending point, it could be your sink. But these controllers give you the properties of the network. Can you go back? And finally, we've got terminals. So terminals traditionally, operational devices have one in and one out. Now with terminals, we have the ability to expand that capability and maybe have multiple inputs and multiple outputs and multiple paths. So go ahead. So if you consider the utility network, the previous release 10.6.1 and 2.2, our focus was on quality, performance, and scalability to really enhance the user experience. The 10.7 and 2.3 release that's coming out now is the release that we anticipate will give utilities most of the things that they need to start going into production. We anticipate that's why we've got so many utilities that are lining up and starting to do their homework. So the 10.7, 2.3 release, and I'll let Hussein do a little bit more of a deep dive, but a couple of things that are important for you to consider. Attribute rule enhancements. We've expanded the capability of being able to manage attribute rules and to be able to have a better user experience to see the SQL queries that run them, to even do improved imports and exports of those attribute rules. And contingent domain values are going to be equally important as well. That's going to sharpen our focus to be able to let our consumers, our customers, be able to do smarter edits. And the geodatabase team will go into contingent domain values. So, Hussein, if you want to take us through some of the details.
Thank you so much, Remy. Morning, everybody. My name is Hussein, and today we'll discuss the technical aspect of the utility network and what we have new for 10.7 and 2.3. I'm going to dive deep into just a little bit of an introduction of the UN, showing you what we have today, what we shipped, just for those who are new to the utility network. And then I'm going to jump into the new stuff that we built for 10.7, 2.3. Then I'm going to talk about attribute rules. All right? So with that said, let's just jump into it. So Remy had an interesting slide where...
We're still on the PowerPoint.
Oh, that's weird. Maybe I have to stop sharing. Just a second, guys. End slide.
There we go.
All right, that's much better. All right, so Remy had an interesting slide where he showed the drivers of why did we build the utility network, right? Customer experience, safety, outage management systems, and these are the business drivers, the strategic that drive us to build this network management solution. But there are also some technical reasons why we started this project, the utility network project. And one of my favorite ways of representing the utility network is it is a service-based architecture dataset. This is actually the first one in ESRI that has a dataset that is exposed via services. What does that mean, right? So traditionally, we always connected to the dataset through the geodatabase, through a client-server manner, right? So you establish a connection from your database, from your client to the database, and then you consume it, right? But that has limitation because I want to be able to executed through the entire platform, devices, iPads, iPhones, right? So how can I do the web? How can I do that? There's one standard that allows to do that, and it's called the beautiful HTTP, right? The web runs on the whole thing, right? And then I really like to talk about this protocol because it's very standard. It's what the web runs on, and this is what the utility network runs on top of as well, okay? So services, tracing framework. So what we took is we created this sophisticated, highly configurable tracing framework on top of the utility network, where instead of having the user, like in the GN days, writing their own custom apps to do a simple trace, we kind of shifted the equation to do more configuration instead of more customization, right? So we're going to show you the tracing framework, and then finally we baked in schematics, right? The schematics diagrams is baked into the utility network. So these are three of the few things that we started the utility network. So and this is the product that is supposed to take the utilities for the next 20 years. Okay, so that's a utility network. So let's jump in and actually show you guys what a utility network looks like. So when I connect to my utility network, this is how a utility network looks like, right? So this is the utility network data set. This is a new trick I learned how to zoom in Windows. All right, so you can actually take a look at the utility network that I have created now, and then what I'm going to go is go ahead and go to the properties and show you what we have for that. So what we're doing here is we're exploring the network properties, the utility network properties. Okay, and just like that, what we see here is we see something called network topology, and this is a key to enable the tracing framework. The network topology is what allows things to be connected in the utility network. So it's like how this line is connected to this transformer, how this transformer is connected to this low voltage line. It's all built in as very primitive, simple junction edges in the network topology, right? But higher level, these are called domains, right? So you can add a utility network, create it, and once you create a utility network, you get for free a structured network. And this is, think of it as like a supporting classes to support your network, essentially towers, poles, things that commodity doesn't really flow through, but you need it to support your utility, right? So that's a structured network. And you can see in my classes here on the right side that you get 3 classes with this: structure boundary, structure junction, and structure line, okay? And then you can optionally add domain networks, and each domain network represent, you can say a utility, like a water network or an electric network or gas network. And you can combine all of these in one utility network, and this is now interesting, right? Suddenly, I can now answer interesting questions between different utilities, like what happens if this transformer that feeds this pump station that actually provide water to my customers, if this transformer goes out, what customers will lose water? You can answer these kind of deep analytics with this, right? So let's not dive deep into this, but that's the utility network. And I want to show you first the associations, concept of associations. So this is a new concept where we can, traditionally, when we connect 2 things together, you need to see them, right? There's a junction, there's a line, there's a point and line, you connect them together, they are connected, right? Customers asked us, like, hey, I really need to connect these 2 points together, but I don't really need to draw a line between them, it's just a waste, right? So that's why we invented the concept of association. And guess what? Just like that, we now extended that for concept of containment. I can say that, hey, this substation is containing these features, this pole has these structures attached to it. So let's go ahead and show you, guys. If I zoom in here, as you can see, things are drawn in the blank, right? But there are actually features here that I decided not to show them. And these are called content features. So let's go ahead and just display those features by showing the display content feature. And you can see that, hey, suddenly all these features are now displayed, right? And these are connected. There are connectivity association between them, but you cannot see them right now, right? Because they don't have geometry, all right? So what we did is like, here's a quick way to visualize these association, right? So the green ones are what we call containment association. So this is the switchgear, and all these fuses and all these devices are part of this thing, all right? So let's go ahead. With that said, let's do a trace, right? I'm gonna do a quick downstream trace from this line, starting point, right? Now I'm using the tracing framework to do that, and you can see all the knobs and whistles and bells that we have here, right? It's a very sophisticated tracing framework. We have a lot of options there, but all I'm going to do is quickly select my tier, which is a medium voltage, and then go ahead and run a trace. What you want to notice is like it's going downstream, right? So it will go run the trace and then trace the entire network. They are somewhere going out the other side, and then it comes back and it stops here. And there's a reason it stops here, and the reason is because we told it to. There is a condition said, hey, when you find a device status that is open, go ahead and stop. And this is very powerful, right? And if we really clicked on this device, it doesn't really say that it is open. It does, right? It says open. Okay, so that's part of the tracing framework. And speaking of the tracing framework in general, today you can do a lot of things with the tracing framework. You can configure things, but we always take the customer's requirement and says, okay, there are things that are really hard to configure and takes a lot of time. And one of them is called the isolation trace. The isolation trace is when, if you're not familiar, is, for example, in the case of gas or water, you have a pipe and there's a leak, and you want to place a starting point there and the leak, and then you want the system to tell you what valve should I close to isolate this leak. Okay? To do that today, with 2.2, you have to do, I think, 5 to 6 traces to determine that. What we did is we introduced in 2.3 and 10.7, we introduced a new trace type we called the isolation trace. And then that will be the pattern for essentially any new trace that we want to introduce. So let's go ahead and place the starting point here, and then isolation. So what we will do is, like, every time a trace is complicated to configure, we will bake it into the system, and just like we did with the isolation trace, right? This is an example. This didn't exist back in the 2.2 and 10.6.1. Okay, so what we're going to do here is I need to filter this, so, hey, go ahead and return for me anything, any device that is operable, right? Because some devices might be like, there's a truck next to it, or it's buried that you cannot access. You want devices that are actually operable, okay? And you can add more and more and more configuration. And you can see, right, just by doing that, we have one device here, and then one device here, and it's clearly said, like, if I closed, yes. If you close these, I always get those confused between electric and water, right? If you close those, you will isolate this entire pipe area, right? Okay. And another new feature we added is called export subnetwork. So export subnetwork is actually an existing feature, but we had a very basic information model out there. So we were previously in export subnetwork, a circuit, if you think about it, or a zone, I would only export, I think, the connectivity, right? Hey, this is connected to that. But customers ask us, hey, we want more information. We want the geometry. We want features. We want attributes, right? Give me if this feature is open and closed, and much, much more information. So we added that recently in 10.7. All right, so that is the utility network part. Let's jump to the attribute rule part. With attribute rules, quick reminder, quick introduction. So what we shipped is, in 2.2, I think in 2.1, is calculation and constraint rule. So if I create a feature, please go ahead and execute this logic for me, right? And this logic is usually an arcade script. And then do something as a result. So a constraint might be, hey, if I create the feature, execute this logic, and if it's true, go ahead and commit this edit. If it's false, abort the transaction. All right, very simple stuff. Calculation is the ability to actually populate other fields in the feature while you're editing, so which is very powerful, right? We're going to show you in the 2.3 and 10.7, we added 2 new attribute rules. The batch calculation and the validation rule, where we, instead of having logic execute on the trigger based, right? It's like on insert, update, or delete. We added an on-demand feature, a batch mode, where you can optionally, if you want, on desire, evaluate rules on demand, right? So do it as a nightly process. So I say I don't really want these rules to be executed on each edit. I wanted to do it as a nightly process. Okay. So let's go ahead and show you some of these rules, right?
Let us speed up.
All right. So we're gonna quickly speed up. All right. Ooh. I'm on. All right. Well, this thanks, and I'm going to go ahead and show you guys the. All right, it's back in. All right. So let's go ahead and try to create a transformer here. Okay. So I have a rule here that if this transformer, this type of transformer, we want to create it, it must exist within a substation. Okay. If I go ahead and create it, it fails immediately, right? And this is the error that we get. And this is a custom error that I created, right? So once I created as in the substation, a lot of things happened here. What happened here is actually what we got is the transformers got created, and we also got the name of the substation. This is the layer-on-layer feature in Arcade, right? Where we can query other layers and provide information based on that, okay? And quickly, I'm going to show you before we go on. And this is the 3 types of calculation, constraint, and validation. This is the new UI that we have for attribute rule. You can go ahead and manage your attribute rules from this. You can see that there are 2 types of calculation, immediate and batch. Constraint, we always had that, and validation is the new thing, essentially, all right? And this is a sample Arcade script. Hope you can read the screen. But in general, this is the feature set by name that is introduced in 10.2.3, where you can actually open another layer and do queries based on it. So what I'm doing here is I'm querying the substation. When I try to create a transformer, query the substation layer, intersect with it using the transformer geometry. If I find a substation, go ahead and get the name of that substation, right? If I did not find a substation, that's the error you saw, right? Transformer must be created in a substation. And then what I did is, like what I didn't show you, is like we introduced a new way of return type to mark other features as requiring calculation or as requiring validation based on the new evaluation feature. All right, guys, I think we're out of time, right? With that said, you guys have any questions for us?
All right, maybe just one question.
Yeah. Sorry, guys.
Thank you for the presentation. It was lovely. I'm curious if the support for 3D is coming with the JS.
So the question was regarding support for 3D. So the utility network is Z-enabled, so you could certainly populate the Z values and utilize it in conjunction with scene. We've done some basic work with that. What we anticipate, and one of the things that I'm excited about, is we anticipate the eventually integration with some of the Autodesk products, so that you can bring in mesh objects or 3D objects to participate as these devices like transformers or circuit breakers and have a true 3D immersive experience. But right now, everything's Z-enabled, so you can replicate in 3D.
Thank you.
All right, we need to move on. All right, let's give these guys a round of applause. Thank you.